Good day and thank you for joining us. So in today's lesson, which is the second revision lesson for grade 10, we're going to be looking at more revision from grade 9 on some basic principles. And today we're going to be looking at products. So at the end, we'll also look at some examples of fractions just to up the level of question just a bit. So starting off here with number 1, we have monomial times monomial. So the very important thing when we are timesing to get products is understanding what we are timesing, okay? So what I want us to always do first is times the numbers that are in front, right? The coefficients. So we'll work on timesing coefficients first. So in this case, we have 2 times negative 3. So 2 times negative 3 will give me negative 6. Once we've done that, we can then look at timesing the variables, right? And obviously when we're busy timesing variables, we need to look out for the exponents. So we can see the exponent here is 2 and the exponent here would obviously be 1. So if we times that together, we get a times a. Remember, bases are the same, so we add exponents. So it's 1 plus 2, that is 3. So our final answer there is negative 6a cubed. Looking on here at monomial times binomial, we do the same thing now, except there is an extra step. So when it comes to timesing monomial times binomial, remember monomial is a single term expression and binomial is a double term, right? So when we're timesing this, we have to times this into the brackets, okay? Into the brackets which contains the binomial. And how that works is our monomial times the first term first and then times the second term afterwards. But remember now, we still have to focus on our steps that I said before. We're timesing coefficient first, then variable. Focusing on that coefficient. The exponent, my bad. So, looking here on our example, so we're going to times negative 3a squared b times into 2a first, okay? And then we'll times it into negative b squared afterwards. So if we times this in, we have negative 3 times 2. Negative 3 times 2 is negative 6. Now we're going to look at the variable over here, a squared times a, that's a to the power of 3, and then b has nothing to times over here in the first term, so b will stay as is. Now we look at negative 3a squared b times negative b squared. Now remember there is an invisible 1 here in front, so we'll times the coefficient first still. So it's negative 3 times negative 1, so negative times a negative, so we get a positive. Now we're going to times a. A has nothing to times there, so we're left with a squared. And then we have b, obviously 1 plus 2 gives us 3. And that is our final answer here for the monomial times binomial example. Okay, moving on here, we have a binomial times binomial. So it's going to be very similar to monomial times binomial, whereas we are timesing this term into the first term and then the second term. But then the added step now is because we have a binomial here in the first bracket, which is timesing the binomial in the second bracket, what's going to happen with the second term as well now is we're timesing with this term too, the first term and then the second term. So we'll focus on term number 1 first. So we'll start here, we'll go 2a times 3a, that gives us 6a squared. And then 2a times negative 2b cubed. So now that's remember the coefficients first. It's a negative 4a, because a is nothing to times, and then b cubed. Now what we do is we move on to this second term over here. And remember the second term is also going to times the first term and second term in the next bracket. So negative 3 times 3, that's going to give us negative 9. Then we're going to have that a, which times nothing, and then b squared. Cool, and then we'll look at the final term over here in this bracket, which we are timesing now. So it's negative 3 times negative 2, which gives us positive 6. And then this is b squared times b to the power of 3. So that is b to the power of 5. And that is the binomial times binomial example. As you can see, there are no like terms in the final expression of the answer, so we can't necessarily add or subtract to get a basic answer. Well, more basic than that. Moving on here to our binomial times trinomial. So once again, we'll be timesing this binomial into this second bracket, following the same principle, except obviously now we're timesing into that third term inside the second bracket, right? And that's why this is a trinomial. So we're going to follow our basic steps. Remember that this 2x is going to be timesing the 4x squared first, then times the 2xy, and then times the y squared, and then the negative y will follow the same sequence. So we're going to go 2x times 4x squared. That's going to give me 8x to the power of 3. 2x times positive 2xy. We are going to get positive 4x squared y. 2x times y to the y squared. We're going to get positive 2xy squared. So now, once we've done that, we can see we have 3 terms now so far in our answer, and that's because we times our first term here into the trinomial, right? Now we're going to move on to our next term, which is our negative y, and that will times into all 3 terms. So negative y times 4x squared, we get negative 4x squared y, and then we get negative 2xy squared, and then we get negative y times y squared, we get negative y to the power of 3. And once again, as you can see, we're going to have a look if we have any like terms. We have 8x cubed. Are there any other x cubes? No, there isn't. So now we have an x squared y. We can see we have an x squared y here once again, so which means that there is a like term present in here. And then if we look again, let's just highlight where our like terms are quickly. So we can see we have a positive 4x squared y and a negative 4x squared y. So we know immediately, because they are additive inverses, they will cancel each other out. Look for any other like terms that might be about. We have positive 2xy squared and we have a negative 2xy squared. Once again, we know that these are additive inverses, so they'll cancel each other out. And so what we are left over with is 8x cubed minus y cubed. So always when we are timesing out to get products, we always need to be aware that even though we've already times out our brackets to get our product, that does not necessarily mean that we are at the final answer. We always need to be looking out if there are any like terms that can be added or subtracted from one another, because that's what will stop us from getting our final mark, right? Because this was not the final answer. This over here was the final answer. So moving on now, we have binomial squared. So binomial squared is a bit it's not that tricky, but it is commonly where most mistakes are made. So when we're looking at binomial squared, the basic setup is we have a bracket here with a binomial inside, and that bracket is being squared. So this squared is basically saying that whatever is here is being times twice, right? So this bracket is being times twice. And so how we'd write that out is x minus 4y squared. So that's the one bracket. Remember, we are squaring this bracket, so this bracket is timesing itself twice. Okay, so x minus 4y squared, and then we write again x minus 4y squared. Cool, so this is how we'll start our questions where we have these binomials squared or these brackets squared, right? So we will write out the bracket twice. And as you can see now, what it looks like is we have a binomial times a binomial. And that's basically what binomial squared means if you say it out, right? So once again, we're just going to follow our steps for binomial times binomial. So we'll start with the first term and we'll times into the bracket, and we'll move to the second term and times into that second bracket as well. So if we start x times x can give us x squared. X times negative 4y squared is going to give us negative 4xy squared. Moving on, we have negative 4y squared times x. So we'll have negative 4xy squared. And then we'll times negative 4y squared times negative 4y squared, which gives us positive 16y to the power of 4. Cool, and then we look if we have any like terms left over. We do right here in the middle. It's negative 4xy squared minus 4xy squared. And so what we can do now is we say x squared. So now we're going to say, because these are both negatives, we know that these are not additive inverses, so there is an answer for it. So it is negative 4 minus 4, that's going to give us negative 8xy squared plus 16y to the power of 4 to give us our final answer. Then moving on to this next one, which isn't necessarily more tricky, it's just a lot more to pay attention to. So once again, we'll write out our bracket twice. 3x squared y minus 2y, second bracket 3x squared y minus 2y. Okay, so we'll follow our steps once again. So we're going 3x squared y times 3x squared y. Looking at that coefficient first, 3 times 3 is 9. X squared times x squared gives me x to the power of 4. Y times y gives me y to the power of 2. Now we'll times this first term into the second term in the next bracket. So 3 times negative 2 gives me negative 6. X has nothing to times, so x squared will remain as is, and then y will times y, and we'll get y squared. See, now we finished that first term in our bracket over here. Now we'll move on to our second term, which is negative 2y. So negative 2y over here is going to times 3x squared y. So negative 2 times 3 gives me negative 6. X has nothing to times, so we'll just bring that down as x squared. And then y times y gives me y squared. And then looking at the final one, negative 2y times negative 2y over here. So we're getting positive 4y squared. And once again, we're going to look for any like terms. Here we have negative 6x squared y squared and a negative 6x squared y squared as well. So once again, they're not additive inverses, so they do have an answer that is not 0. So 9x to the power of 4 y squared minus 12x squared y squared. That was minus 6, which gave me negative 12. And then we have plus 4y squared, and that gives us our final answer. So moving on to our last two examples here, which are just a bit trickier because we're dealing with fractions now in our products. So what we got here is a 5 times basically what is a binomial times a binomial, right? So usually how I like to start these is I like to times this number into the first bracket over here. Okay, so if we're going to do that, so this is basically first going to start off as a monomial times a binomial, which will leave us with two binomials at the end, and then we'll times those two binomials together, and I'll show you what I mean. So it's times this monomial into the binomial, so 5 times a, and then 5 times negative a fifth. So 5 times a will give me 5a, and then 5 times negative a fifth will give me negative 1. So basically how that works out is it's 5 times a fifth, or 5 over 1 times 1 over 5. And we times our fractions, numerator times numerator, denominator times denominator, so we're left with 5 over 5. And we know that if the fraction does work out this way, it's equal to 1, where the numerator is equal to the denominator. So right now we have our first binomial times our second binomial. So all we need to do now is times out these two brackets. So 5a times a gives me 5a squared. 5a now times a fifth is going to give me, so 5 times a fifth gives me 1, as we know. So that's plus 1. And then a has nothing to times on that side, so it's just 1a. And now we have negative 1 times a, which gives me negative 1a. And then negative 1 times a fifth, which will give me negative a fifth. And obviously, as we can see, we have additive inverses here, so that's positive 1a and negative 1a, so they'll cancel each other out. And then our final answer we're left with is 5a squared minus a fifth. And so now we'll move on to our last fraction example over here, which seems to be a binomial squared. So let's just start off by writing out our two brackets. So we know it's going to be a half x minus a third y, and that is squared. Oh, sorry, my bad. We're writing out both of our brackets. So we're not writing in the squared, we're writing out the second brackets. Okay, so we know now that we need to times this first term into both terms in the second bracket, and then the second term into both terms once again. So if we're going to do that, we're going to go a half times a half. So we times numerator by numerator, so we're left with 1, and 2 times 2, which is 4. X squared. Cool, that's x times x, so it's x squared. Now we're moving on to a half x times a third y. So what we left now is, so it's negative a third y, so we get a negative 1 over 2 times 3 is 6. And so we have a variable of x and a variable of y. Now we'll move on to negative a third y, and we'll times that into the second bracket. So we end up getting first negative 1 over 6 x y, and then we have negative third y times negative third y, which gives me positive 1 over 9 y squared. So now looking at this, we have like terms over here in the middle. This is because they both have xy. So how we're going to do this is, so we'll first go a quarter x squared. And so they're both minus, so we know that our answer is going to be a negative as well. And because these bases are the same, we can basically just do, because remember we're looking for that lowest common denominator if we're adding or subtracting fractions. And that is obviously going to be 6. So which means that the numerators will not change. So we're doing 1 minus 1. Sorry, it's negative 1 minus 1, which gives us negative 2. That's over 6, right? And we have x, y as our variables, plus a ninth y squared. And so basically now we need to look, is everything in its simplest form? Quarter x squared, that is in our simplest form. 2 over 6 though, that is not in its simplest form. We can get down to a simpler fraction. So what we're going to do is we're going to get a quarter x squared minus, so how can we make this smaller? We know that if we're going to simplify the fraction of 2 over 6, we are going to get 1 over 3 xy, and that's plus a ninth, which is in its simplest form, y squared. And that will be our final answer. Okay, well guys, thank you so much for joining us. That will be the end of our second week of revision before we start our grade 10 topics. Thank you.